Alright, today we will be learning about dynamics on an inclined plane. An inclined plane is a flat surface whose endpoints are at different heights. By moving an object up an inclined plane rather than directly from one height to another, we make the task easier. The inclined plane is a machine. A machine is any device that transmits or modifies force applying to an object. All machines are combinations or modifications of 6 fundamental types of machines, called simple machines. There are 2 forces acting on the body, sliding on the inclined plane. Normal force, that is perpendicular to the plane, is exerted by the plane onto the body of mass m. The weight of the object acting vertically downwards, g, equals acceleration due to gravity. The gravitational force is replaced by its 2 components, a force parallel to the plane, mg sine theta, and a force acting into the plane, mg cosine theta, which is equal and opposite to n. Theta equals the angle of elevation of the plane measured from the horizontal. Newton's second law written along the y-axis gives n minus mg cosine theta equals mass times the acceleration in the y direction, which equals 0. And along the x-axis, it gives mg sine theta equals mass times the acceleration in the x direction, which equals ma. Therefore, acceleration equals gravity times sine theta.
Right here, we're going to show how forces act on an inclined plane. Right now, the forces acting on it right now is force normal, which is perpendicular to the surface of the track, and force weight, which is acting as gravity. And when we use force applied, it causes.
So you have to push the cart to move. Okay, for force applied. Thank you.
And also, force friction is not applied.
Find the acceleration of a person sliding down a snowy hill as pictured if the coefficient of friction between the sled and the snow is 0.33.
So right now we have force perpendicular to the surface is Fn plus Fg cosine 28 degrees equals Md perpendicular equals 0, and our force parallel is Fg sine 28 plus force friction equals Md parallel. So from the perpendicular direction, Fn equals negative Fg cosine 28 degrees, and from the parallel direction, we got Ma parallel equals Fg sine 28 degrees minus mu of Fn going to the right. So to continue, we got Ma parallel equals Mg sine 28 minus U Mg cos 28. And acceleration parallel is G sine 28 minus U cos 28 degrees. So our final answer, calculating all of this, our acceleration parallel will equal 1.7 meters per second square down the hill.